Hello students. Today we will discuss the second part of topic corrosion, that is mechanism classification of corrosion. In the previous lecture we have already discussed about what is corrosion, and the first classification, that was oxidation corrosion, we have already discussed. In this lecture we will discuss about the second type of classification, peeling Bedworth rule. According to this rule, if oxide layer is protective or non-porous, the volume of the metal oxide formed is greater than the volume of metal. And the second case is, if oxide layer is non-protective or porous, the volume of metal oxide formed is less than the volume of the metal. The examples of protective layer metals are aluminium, tin, lead and copper, and the examples of non-protective metals are lithium, sodium, potassium, magnesium, calcium and strontium. And this rule is related to the first classification, that was oxidation corrosion. The second type of dry corrosion is corrosion by other gases. According to this, if other gases present in the atmosphere like SO2, CO2, Cl2, H2S can also attack on the metal surface. For example, if chlorine attack on silver, it form protective layer of silver chloride and it prevent further corrosion. It means on the surface of silver, further corrosion will not be possible. The reaction is Cl2 plus Ag converted into silver chloride. And the second example is tin react with chlorine present in the atmosphere and it form SnCl2, and this layer is volatile in nature. And we have already discussed that if volatile layer will form, the corrosion will be a continuous process, and in this case it form volatile film. Reaction is Cl2 plus tin converted into tin chloride. Third is liquid metal corrosion. In this type of corrosion, the chemical action of flowing liquid take place at high temperature on solid metal, and this type of corrosion are found in nuclear power plants. And these all are the types of dry corrosion. And the second classification of corrosion is wet corrosion or electrochemical corrosion. This type of corrosion occurs when the first condition is the conducting electrolyte liquid is in contact with the metal. The second condition is two different metals are partially dipped in the electrolyte. In the above condition, one part of the metal become anode and the remaining part become cathode. In anodic area, oxidation reactions will take place, and oxidation means loss of electrons. The reaction is metal converted into metal ion and it releases two electrons. And in cathodic area, reduction reaction will take place, and these type of reactions depend upon the nature of electrolyte solutions. And in cathodic area, two type of reactions will take place, depend upon the environment. First is hydrogen evolution mechanism and the second is oxygen absorption mechanism. The first is hydrogen evolution mechanism. When the conduction medium is highly acidic or completely free from dissolved oxygen, hydrogen evolution will take place. For example, corrosion of iron metal by industrial waste containing hydrogen ion undergo this type of corrosion. In this type of corrosion, anode contain large surface area and less cathodic area. The reactions are: at anode, oxidation reaction will take place. It means electrons will be released at anode. The reaction is Fe converted into Fe plus 2 ion and it releases 2 electrons. At cathode, reduction reaction will take place and the electron that was released at anode move anode to cathode, and the hydrogen ion present in environment accept the 2 electrons and convert into hydrogen. And the overall reaction is Fe plus 2 hydrogen ion converted into Fe plus 2 and it releases hydrogen. Second is oxygen absorption mechanism. This type of mechanism take place when the base metal are in contact with neutral solution like H2O with dissolved oxygen. Example of this kind of corrosion is rusting of iron. If there is any crack in the paint coated iron, the area act as anode. The liberated electron flow from anode to cathode through the metal, accepted the electrolyte and oxygen at cathode, and the reactions are: at anode, oxidation will take place. Fe converted into Fe plus 2 electrons. At cathode, reduction will take place in the presence of neutral medium, half oxygen plus H2O, and it accept the 2 electrons, convert into hydroxide ion. The overall reaction is Fe plus half oxygen plus H2O convert into Fe plus 2 hydroxide ion convert into ferrous hydroxide. If enough oxygen is present, ferrous hydroxide is converted into ferric hydroxide. The reaction is as follow: ferrous hydroxide in the presence of excess oxygen converted into ferric hydroxide. The